All right, good morning. Happy New Year. Nice to see every one of you. I don't think I recognize many faces here. I guess none of you took a course with me before, which is good. So everybody's new here, except for maybe one or two. Anyway, so 3342, System Specification and Design. Right, just make sure you're in the right class. And I'll definitely talk more about the course content a little bit later today. But I think the main task today is today's class is to make sure you're familiar with how we're going to run the course and also how you're going to gauge your grade for the course. Okay? Quite a bit of details that we need to watch out for, so let's do that. Hopefully in the first 40 minutes or so, and then we'll cover some other stuff. Alrighty. Okay. And if you don't know me, Jackie. So that's how I prefer to be called. I'm quite informal. You don't need to be formal. But if you want to call me Professor Jackie, Professor Wang, that's fine. Okay, Jackie's most preferred. And if you need any advice on the course, speak to me early rather than late. Especially, maybe try not to speak to me only after you perform poorly in the test, or maybe getting too close to the exam. Speak to me earlier, so I can maybe give you some more advice on how you can master, the course material. And there will be 3 bonus opportunities for you guys, really to help you guys, get as high grade as possible. Number 1, there will be a midterm survey, which I will conduct over the E-class during the reading week. So as long as you guys hit certain response rate, then I'll give you guys some bonus. But it's going to be completely informal and anonymous. The second opportunity will be the end of the term course evaluation that's formal, right? You can also participate in that. And the third bonus opportunity, I'll elaborate a little bit more, but that one is more about attending the class in person. So we're going to use an app on your mobile phone called iClicker. I'm not sure any one of you actually used that before. If you have, then good. If no, very straightforward to get it installed. I'll talk more about it. And anytime you want to suggest any way to improve the way you learn, let me know, and I'll see if I can adapt. And if you're not enrolled in the course just yet, maybe you're still in the wait list, and you want to really reach out to me as soon as you can by giving me your name, your student number, and passport, your ID. So I'm going to add you to the E-class so you can get access to the lab instruction. I'll talk about labs a little bit later today. And you want to keep up with the study materials and also complete your labs and also do the test. No extension. All right. About the mask, I don't need to say more. It's optional, but consider for yourself. Make your own decision. And I will just be very grateful. If you do come to my in-person office hour, I'll be very grateful if you can wear a mask. Okay, much appreciated. Otherwise, in class, do what's really feeling comfortable for you. And just a little bit more protocol, so please just avoid talking. And if you really need to do it outside. No problem with it. And the slides are typically quite self-contained, containing lots of bullet points and lots of details. But what I will try to avoid is to simply read off the slides. May not be worth your time since you're come all the way here. I'll try to maybe walk you through more examples and more visualization and more explanation that may not be actually on the slides. That's something I would like to do, okay, in general. And ask questions anytime. I don't mind being interrupted. Don't be shy, just interrupt. Writing emails to me, I'm very informal. Just don't need to be formal in the email. Just don't be too rude. You can see some example here. I'm not going to bother you with that. Take a look later. And course information. So there will be 2 sites you have to monitor regularly. Namely, one will be the E-class for sure. That's where you received my announcement about yesterday. The other one will be where you can find the lecture materials for all your study. And that one is public domain. You don't need any like a login. Even beyond the class, if you want to look through the materials, you can still do it. I'll go over them one by one. The first one will be the E-class site. And let me just go there very quickly. Okay. Hopefully, I don't need to verify myself once more. There we go. Oh, guys, by the way, so a very sound look ahead. So for there are 2 kinds of midterm for you. One will be the so-called programming test, and the other one will be more like a written midterm. And that midterm is going to take place on the E-class, meaning that if you go to a physical lab to take the E-class midterm, you want to make sure you can do the dual mobile verification if needed. You want to make sure you don't waste any time. So the best preparation is to try out, right, before the test. But I'll talk more about it. On the E-class side, definitely look through the announcement every once in a while. Sometimes maybe your email account wouldn't catch that announcement. And then study material, if you click on that, that will be the second site, which I'll also go over with you. And there will be some textbook for which my slides will be based on. Do you need to read it? I would say to perform well, you don't necessarily have to read it. For those of you who just want to find more examples and more explanation, maybe more formal explanation, you can definitely go to the textbook. The PDF has been permitted for us to study under the assumption that you don't really distribute it, right? That's okay. You can just use it. But you can also find the actual information. If you really want to purchase the book, I'll leave that to you. You don't need to for this course. And so far, we only got these sections, but later on, you can expect there will be one section for your lab instruction starting from next week, week number 2. And also, there will be one section for some example, maybe E-class midterm, maybe before your test 1 and test 2. I'll talk more about it, about the dates. That's pretty much the E-class site. You cannot really find any slides or recordings over here. I put it on the second site. Okay, I'll go over that with you later. Okay, let me go back to the slides. Let me just switch this, if I may. Okay, announcement, lab instruction, written test, and check your emails regularly. Okay. All right, and the second site will be the site which I referred you to yesterday. So it's under my EECS domain. It's very easy to find. You just search for Google me, Jackie Wang, and then York U, and you can see my home site. Go to the lectures, and you can find here. Very easy to find. So several links you can pay attention to. For my office hour, it can be either in person, so this will be my campus address, or you can join in over Zoom if you prefer. Either way, it's okay. But if you want to join over Zoom, just click on the link. Then you can see, you can join my Zoom meeting room. And then this is completely optional. Since we're going to use an IDE called Rodin for your lab exercises, so if you wish to maybe back up your work more professionally, you can definitely consider GitHub if you haven't done so. That's tutorial videos I recorded a little bit long time ago, about 5 years before, but I think the critical ideas are still there. It's not exactly out of date. Okay. But if you run into any trouble, you can reach out to me or the TA. And you can see here, this section over here, we got course syllabus and the slides I'm currently presenting, and the weekly schedule, and also semester calendar. We'll go over them page by page in just a moment. But you can definitely refer to them. And for the course syllabus, according to the Senate policy, there might still be some edits until 2 weeks later. But I don't think it's going to happen. But just in case it really happens, I'll let you know for sure. And then this table over here, you can just see that growing over the weeks. So every time after our lecture, I will try to release the lecture recording on the same day. I will try to. If I really cannot, I'll definitely try the next day. But if you already come to the class, you already know what's happened. So it's only for your review purpose the next day. And you can see the slides. Hopefully, I can get into about introduction to the course. And that one there, you can already see the copy. So typically, I may not be able to finish the entire PDF in a single lecture. We may have to take several classes to really do it. Especially, there will be one very huge case study that will take us weeks to really complete. In that case, it is up to you if you really want to print out the intermediate version or you just want to use a PDF. But until I really say the slides are final, there might still be some edits, maybe some typos, maybe some extra slides, depending on how we learn. Okay, just to give you a little bit warning. You don't want to waste your print quota. That's limited. All right, so that's the second slide. You can definitely expect it to be grown throughout the semester. And the course syllabus, let's go over that. Before that, do you guys have any question or concern up to now? Good. Let's now do course syllabus. Oh, where can you find it? The version I'm going to present is already on this study site here. If you click on course syllabus over here, you will see that copy exactly over here. Right? It was just last updated yesterday. Okay? I don't expect any major updates, really. We'll see. Unless maybe there's some terrible mistake I made on the syllabus, but let's see. Okay, just make sure everybody can see it. All right, course policy. About your lab exercises over here. Well, you can definitely read through the text, but let me tell you the principle, okay? Number one, for your lab exercises, submissions will be required, number one, okay? Number two, before the submission deadline, you are allowed to collaborate and discuss solution with your classmates. It will not be considered as cheating, number two. And you can also come to myself or the TA to ask for some solution hints. That's also considered fine, number two. Number three, as long as you can really submit your best attempt before the submission deadline, you will get 100% for the labs. In total, there will be 10% of your course grade. That's based on the lab submissions. So we trust that you really try your best before the submission deadline and also make your best attempt to really submit before the deadline. And you can get your 10% automatically. The rationale is we don't want to give you too much stress while you're learning the contents by doing the lab exercises. But how do we evaluate you? There will be 2, I quote, programming tests at some point after the reading week, in which case we're going to test you on what you're supposed to learn in the lab exercises. So take your time, be honest, and try to learn the material before the submission deadline. All right? Hope that's clear. And that's kind of like a new policy I only started doing from the last fall, and I kind of like it. I think we'll see how that goes for you guys for this term. Okay, just make sure you can still read over this part over here to make sure you understand it completely. Do you guys have any question about this lab assignment policy here? There will be 4 labs, by the way, so 4 submissions required. You have to make sure you submit before the deadline, all right? And of course, for your scheduled tests, which I'll talk about, we got 4 scheduled tests in total. But of course, no collaboration. We'll actually invigilate the test just for fairness. And plagiarism is only applicable to the scheduled test. For your lab assignments, it's basically just for your learning. Ask for any help you might want. You get your 10% very easily. Okay? And of course, for your lab deadlines, yeah, very stringent. That one is straightforward. And late enrollment, you want to make sure you actually send me the details so I can add you to the e-class. Okay. And about the office hour, you can send me email. Since we already resumed in-person learning, so I don't mind if you just schedule some in-person appointment with me or come to my office hour. That's actually more preferred. We can have better communication. Sometimes, over the emails may not be so easy for us to communicate. We'll see. And my office hour, okay, that's important. Let me highlight. It's going to be 3:30 to 4:30 p.m. on Tuesday, Wednesday, and Thursday. You can either come to my office in Lausanne building, 2043, that's my room, in person during that time, or you can simply try to join over Zoom. But please just understand that I'm going to give priorities to students who already show up in my office. But once I have helped them, I'll definitely answer your Zoom call. So just understand that. You may just have to wait a bit. Okay? All right. And for the venue, for the lectures, you guys know, pretty sure you know about it. And also, we are now in the winter season. Just in case the weather is so extreme, in that case, we may have to cancel the class, or university might simply just be closed. In that case, I will definitely send you some notice beforehand. And what should we do instead to make up the hours? I will either try to schedule some Zoom live lecture in the original class time, either that, or I will give you guys some good quality lecture video to study. So don't worry, nothing's going to be delayed. Okay, we'll definitely handle that. And for your scheduled lab over here, there will be 2 sessions over here. Let me tell you over here. Number 1, lab attendance will be optional. Meaning that if you don't go, you won't get penalized for any marks. That's number 1. Okay. Number 2, why should you attend the labs? To maybe ask questions related to the lab exercises. So we don't try to do any grading in the scheduled lab session. Okay. So that's the principle. And for week number 1, no lab. I'm still preparing for your lab number 1. I'm finalizing it, so it will be released next week. Okay, it will definitely be released in advance of your lab sessions. Week 1, no labs. And for the E-class site, I already mentioned that. You know how to get there. And for the study materials, basically we got just this site, which I also went over with you to find the lecture materials or any extra exercises, maybe some proofs, which we did partially. And about the textbook. For those of you who might be interested in maybe purchasing a textbook, I just included the information over here. It's quite a classic one to learn about refinements, which we're going to talk about for sure in this course. And it got very substantial examples. Of this semester, we can only cover possibly 2 case studies in 100% depth. That's the plan. But I would rather you understand more clearly about how each step of a refinement should do rather than just covering so many examples, right? So many case studies. We'll see how that goes. And just make sure you don't really distribute the PDF copy. Just keep it to yourself and to your classmate, okay? And I got some copies of the textbook. If you're interested in taking a look before you purchase it, feel free to drop by my office hour. I can show it to you, okay? And what will be the available help resources? Of course, my office hour, which I just announced. And if you really cannot make it to my office hour, appointments, no problem. Just in general, I cannot make it to Fridays, just in general, just to let you know. And there will be TA office hour. I'll try to also make it flexible for you guys. I know you guys are very busy, engineering students, very packed schedule. So the way it's going to work, I will announce the email of the TA or several TAs on the E-class. If you guys have certain questions that's outside the office hour, you can email them and ask them when will they be available for some Zoom chat or maybe even in person help. I'll leave that to the TA. If the TA thought they can do some Zoom chat with you in 10 minutes, then there you go. You can do it. I'll also ask the TA to track the time that's being used just to make sure it's fair use. Anyway, so that's really to you guys' advantage. I'll give you more details about TA's email later on the E-class. And the scheduled lab session, as I said, optional and starting from week number 2. So I'll make sure you receive the instruction for lab 1 before next Tuesday, for sure. And I can give you a little bit of look ahead. So your lab number 1 is going to be about following some tutorial series which I recorded about using Rodin, the Rodin IDE, how you can do specification on the IDE. And then there will be some exercises for you as well. You'll be given 2 weeks to do it. Okay. We'll also give you a solution about a lab too. Okay, prerequisite, I'm pretty sure you guys are fine. And specifically, 1090 will be your friend for this course. It's going to be very math heavy, discrete math, not continuous math. Sets, relations, predicates, proposition. And by the way, do you guys remember, just checking, do you guys remember what this really means? Right? For awesome. And oops, not this one. There exists, yes. But if you are not exactly sure some property about it, don't worry. We're going to spend maybe 1 or 2 classes reviewing to make sure you're ready. Okay? The case study we're going to do rely on these foundational. Okay? And course description, don't worry. We're definitely going to cover that. And the one we're going to use is called event B notation, event-based system. And since you guys will also take 4315 next year, that'll be the sequel to this course. And there's something I want to just mention in the beginning. I'll try to elaborate more on that notion. In EECS 3342 and also EECS 4315. Okay? In this course, we learn about a foundational approach called theorem proving. Literally, it means you have to prove theorems more often manually in the context of this course. Rodin, the tool we're going to learn, also has a prover, but that prover is actually quite tricky to use. Unless we are ready to spend about 1 year or more on that prover, it will be very difficult and confusing to really master that. So what we're going to do is, after the reading week, we'll give you 2 lab exercises to use the prover in a very restricted way. As long as you can master just that restrictive frame we give to you, you're fine, but not in general. Okay, theorem proving. So we definitely talk about how you can do theorem proving for some, for example, bridge controller or FTP transfer protocol. These are the two things we're going to talk about using theorem proving. And 4315, which you will take next year, possibly with Frank. He's currently on sabbatical. But anyway, so he will be teaching that in a consistent way. That one there is more about model checking. Okay. If you haven't heard about the terms, that's okay. It's not really meant to be at a very undergraduate level concept, but you guys are lucky. We can learn about both courses before you graduate. So theorem proving tend to be more manual. Model checking tend to be more automated. That's definitely one fundamental distinction you can think about. So let me describe model checking in a very intuitive way, since we wouldn't really cover that in the course, but it's good for your knowledge. In the case of model checking, all you got to do is specify predicates like what you did in 1090 about your system. And then somehow there will be a tool called a model checker. They can formulate your system as a graph. It's called a label transition system. I know you guys didn't really take EECS 2001 about finite state machine. Have you heard about the term before? Finite state machine. So you can think about the model checker basically is going to build a finite state machine for your system with many nodes and many edges. And then this is a graph, which you actually saw in 3101 or 2011. There, the model checker is going to systematically explore or traverse this graph in such a way that it can decide whether certain properties can hold on every possible state or every possible path of your system. That's basically what a model checking will do. And model checking actually has been used substantially in the industry. And in 4315, I will also mention that Amazon Web Services actually use a model checker called TLA+. For those of you who might be interested, you can definitely look it up, just for your knowledge, TLA+. Amazon actually use it for some certification of the correctness. Anyway, keep in mind, in this course, we're going to learn about theorem proving. But to put that into longer perspective, you're also going to learn about model checking next year. Okay? It's really hard to say which approach is better. I would say they complement each other. Okay. And course learning outcomes, let's not worry too much about it. It will be satisfied at the end of the course. So it wouldn't make too much sense to bother you at this stage. Okay? Guys, are we okay so far? Before I talk about the grading scheme, which is definitely important, right? All right, let's take a look. As I mentioned before, the 4-lab submission, 10%, you will definitely get it as long as you submit before the deadline. And please, we wouldn't check, but you will be responsible for yourself. Make sure that's your best attempt. Okay? And then, of course, we'll try to also assess whether or not you really, learned about the course learning outcome from the labs in the programming test. I put it in programming in a way. It's not like a Java programming, but you got to use an IDE to really complete certain projects. You will see exactly what I mean when you go through the tutorial videos for Lab 1. But there will be 2 programming tests using the Rodin IDE. I'll write it down here. And it will be 10% each, so you got 20%. Okay? Also, there will be 2 written tests over E-class. Mostly multiple choice. There might be some written question for you to maybe write a proof or possibly to justify a certain property or maybe to recall some definition. It's possible, but I would say mostly multiple choice. And I will try my best to give you guys some example questions so that you can get a little bit more prepared. But there should be no replacement for your actual study. Okay? Multiple choices. Okay? And that one, 2 of them will be 20%. And the remaining will be your exam, which is cumulative. I am a firm believer in such substantial and cumulative exam. I know some of my colleagues or some other researchers, they don't like it. They thought everything should be equally distributed and the exam should be very light. That's okay. I respect that opinion. But for me, I do think the cumulative exam that's substantial is really the best way to really for us to know for us as the instructor to really assign you a grade, we would like to know how well you can put everything together and apply to different problems in the actual exam. How about for you guys? You really want to really study everything constantly and also review different parts, try to connect them together so you can synthesize all the topics together in the exam. Anyway, that's how we're going to work for this course. And I just wrote it down exactly over here. Okay? And since we know your exam is going to be 50%, on the one hand, if you didn't do so well before the exam, that would be your opportunity to really still get a very decent grade. Of course, symmetrically, if you did very well before the exam, but you didn't study too much for the exam, well, then you might still actually got some lower grade than you expected, right? So it depends. Guys, any question about the grading scheme? Any question? I know I was asked by another course by one of my very good students. He did ask me whether we're going to drop possibly the test with the lower marks. For now, no. Okay, so please, every test counts. Because every test, they are not cumulative. They will cover distinct range. So you want to make sure you really prepare well. Yes, please.
So you say the exam is cumulative?
Yeah.
Does that mean it will involve rodent?
Good question. The question was, if the exam is cumulative, is it going to involve rodent, or is it going to involve any programming part? The exam, okay, let me just try address that properly. So the exam is going to be in person, and the date is going to be scheduled by the registrar office. So please make sure you don't make any travel plan for your summer just yet in that period. Number two, it's going to be completely on paper. So we don't expect you to really use the rodent tool on the exam. But can we ask you questions related to rodent? Absolutely, we may. But maybe we'll just ask in a way that's actually easy, convenient for you to answer. Oh, maybe I can give you more example later, but definitely, yeah. It's a good question. Any other question, guys? All right. Anytime. Okay, so final exam. What about expected weekly workload? This is just a standard that's actually set by Lassonde. Let me just mention that briefly. You might find yourself able to do less, or just do around the range, or do more. All possible, okay? But for every credits, there will be 3 to 4.5 hours expected to do everything that's involved in this course. So for our course, it's 3 credits, so between 9 and 13.5. You might find some weeks, for example, this week, maybe you wouldn't need to do that much because we don't really give you the lab just yet. But in the weeks where you got lab submission due, and also at the same time you got some midterm, either programming test or written test, of course, there might be more hours. So hopefully they'll even out at some point. Definitely, please come to the lecture, and I'll talk about how you can get bonus for attendance in just a moment. Come to the class, that'll be 3 hours per week, and also for your scheduled lab, it's optional. You can just go there. I'll try to be there as often as I can. If I'm there, you can feel free to speak to me if you cannot make it to my office hour. And also TA will be there too. And yeah. All right, lab assignment, yeah, study, yeah. Pretty straightforward. Okay. And, so I was asked some very interesting questions yesterday in my 2011 class. And students are wondering if there's any 50% rule. Have you guys heard about it before, 50% rule? Okay, the 50% rule goes as follows. It doesn't matter before the exam how good or how bad your marks are. If you fail the exam, you fail the course. But don't worry, we don't have 50% rule in this class. I just want to explain to you, just for your knowledge, don't worry. But given that, guys, relax. Sorry. Given that your exam is 50%, if you did very, very badly, I still hope you will pass. But I'm just saying it's more, less likely you'll pass. But if you have a very good magic to say you did very poorly in the exam, but somehow you did very well before the exam, your raw marks might still be a passing mark. I'll still pass you. Okay? Let me make it very, very explicit here. No 50% rule. I know some of my colleagues has been doing it. No opinion. I think for me as a student, if I keep my study pace, I don't see if I should really care. Anyway, so don't worry, we don't have that. And all we're going to do will be something very standard. We're going to do the weighted sum of all your test, lab assignment, and exam, and see what your roll marks is between 0 and 100, and then assign the letter grade accordingly. And I wouldn't include the mapping over here. It will be completely standard. For example, 90% will be A+, 80% will be A, and etc. Or passing mark, 50%. Okay? Alrighty, attendance. Okay? And this page and the next one here is just to make it very well documented, so that's something you can assume I'm going to do it faithfully when I calculate your grades. But let me just put it quickly, shortly. So I think on Wednesday, sorry, today is Tuesday, right? Sorry, I just got myself confused. On Thursday, we're going to do a trial attendance check unofficially, just to make sure we know the process. Starting from next Tuesday, we're going to do attendance check. And I don't necessarily do attendance check every class. I might do that on Tuesday sometimes. I might do it on Thursday sometimes, but sporadically. Okay? And the way it's going to work, let's say if we take attendance check for 10 times, let's say throughout the term. In that way, if you show up in 90% or more, you get 5% bonus. It's a letter grade. I definitely hope that will help you. Because your exam is going to be quite challenging. It's cumulative, right? It's also 50%. So hopefully this letter grade will actually help you. And etc. So if you show up for 80% or more, you got 4% bonus, and etc. If you got less than 50% showing up, you got no bonus. Okay? Hopefully that sounds fair. And don't get me wrong. So you don't really get penalized in any way in your marks if you don't show up to my class. That's okay. But I do want to encourage you to really show up, see your lecturer, and see your classmate, and then have some chat about the course material. That's my intention. So just come. Okay? How do we take attendance? Okay, so what I need you to do, please, before Thursday is this. If you can just go to this site over here, okay? There's a guide for setting it up. If you haven't really used it before, you will need to create an account in the iClicker. And please make sure there is one section called for courses using eClass. Do not choose this one. We don't really use eClass for our attendance checking, right? You want to choose the section for courses not using eClass integration. And also, please make sure you actually supply valid student number and also valid my.yorku.ca. At the end of the term, when we have done all the attendance checking, I'm going to download from iClicker some spreadsheets showing all your records. How do I really check to see how much to assign to you? I need to look at your student number. So if that's not valid, then you may not really get what you're really supposed to get. So please make sure you double check before you submit your account creation. And then you want to find this particular course over here. Should be easy. I think as soon as you find 3342, there should be just one hit. But just in case, multiple hits, you can see which one. Okay? And I'm going to show you exactly what we're going to do. But make sure every time when you need to respond to the post or when you join the course, if there's such a prompt to you, you want to make sure you allowed the location service to be active. So this is to make sure only those who's geographically around this area can take attendance. So you cannot really do it from home, right? To be fair, right? That's about the attendance checking. So guys, please make sure you install iClicker on your mobile phone or your computer, doesn't matter which one, and then we'll do some trial attendance check on Thursday. Starting from next Tuesday, we'll make it official, okay? That's the plan. Sorry, some question there? If you have no mobile, you can use your computer, or it has to be either way, either your computer or your mobile phone.
Oh, okay.
Okay.
Because I've always got it on my computer and don't have it on my mobile.
Yeah, okay, no problem. Yeah, please try to avoid this as much as possible. Sometimes, let's say if your mobile phone doesn't really work, it's okay for you to come over and write your name on a piece of paper. I can also take it, but please try to minimize that. That will be creating some extra work for me, which I don't mind, but not too often, okay? Alrighty, let's now go over the semester calendar so you know exactly what's going to happen. And you can definitely get a more zoom in, a better version. You can print it out or you can save that somewhere convenient for yourself. So if you go back to the second study site, if you go for the semester calendar, so you can see the PDF version for that. Let's take a look. Okay. Let me go there. Okay. Let's take a look here. So we are now here, lecture 1 for today, right? You can see we got 2 lectures, very straightforward, we go up to 24 lectures. Of course, some of them will have to be either, may have to be Zoom in case it got canceled because of weather, and some of them will actually have to be also lecture videos because, I'll explain. For our written test and programming test, we'll actually need to use the class time rather than the lab time. Let me explain that once we get there. So your lab number 1 is supposed to be completed within 2 weeks over here. Week number 2 and week number 3. If I may, I'll keep the release time a little bit flexible. But since your lab is going to take place on Tuesday, the first one, I'll definitely try my best to release it before your Tuesday lab session for sure. But I'll definitely try maybe Monday. So you can even take a look before you decide whether you want to drop by the lab session to ask questions. Right? So you've got 4 labs in total. Lab 1 and Lab 2 will involve no prover of the rodent. And lab number 3 and 4. Okay, let me just give you a little bit of notes over here. Lab 1 and 2 will focus more on the specification using rodent. And lab number 3 and 4 over here focus more on the proving part. Okay. And your very first assessment will be written test number 1. Okay? Written test number 1, you can see I put it on 16th. So that means, what does that mean? Okay, I'll write it down here. It's also on your syllabus. Written test number 1. Number 1 is going to take place in the Wayland Small Center. Do you guys know where it is? Around Tim Horton, right? Wayland Small Center, or look up the map. I will confirm the room a little bit later, but I believe I already reserved 1 room for our class, 1 or 2, possibly 2 will be enough. And also, it's going to take place during the class time. Not the lab time. So for your written test 1, what should you do? You want to show up in the Williams Small Center Sound Lab room, which I will confirm, at 11:30. Okay, and then the written test, I haven't really decided exactly how long the written test will be. I'll tell you a typical one. That's actually true for last year. So for the written test, it's going to be roughly 30 minutes. Multiple choice, mostly. And for your programming test, it will be running in the same venue, also in Williams Small Center, also the same time, during the class time. But that one there is going to be approximately 1 hour. Okay, so you got more time to play with the tool. Okay, but at about 1 week before each test, I'll give you some guidance, some guide, and also some example questions, so just to help you get prepared. All right, so we got written test 1 before the reading week. We got programming test 1 after the reading week. And you got written test 2 and also programming test 2 in the last 3rd and last 2nd week. All right, that's the plan. I don't think the test dates will really be changed unless, let's say, maybe on the test day, weather was really bad, or I can tell you what happened to 2030 last term. Somehow, when we were having our programming test, about 5 minutes into the test, there was a fire alarm triggered by system malfunction. So we had to cancel the test and postpone that. But it doesn't happen often, don't worry. So in case that really happened, we're going to find a reasonable way to really reschedule that. Don't worry. I just want to mention that just in case it happened. All right, so we got 4 tests over here. What about coverage? Okay, tentatively, let's make something reasonable. For your written test number 1, it wouldn't be fair to cover lecture 11, too rushed. Okay, it will cover from lecture 1 to lecture 10. But in the guide I'm going to send to you, I will confirm exactly what slides and what materials you need to study. Right? But that's roughly the plan. And for your programming test 1, it's going to cover lab 1 and lab 2. So once you complete your lab number 2, you still got your reading week to maybe get some last-minute study for that. And for your written test number 2 over here, it's not going to cover this. So it's going to cover 11, 12, 13, 14, 15, 16, 17, 18, something like that. And for your programming test 2, it's going to cover lab 3 and lab 4, focusing more on how you can do proofs in a restricted way in Rodin. Okay? And of course, the exam. Sometime in the exam period. Of course, we'll see how early or how late the exam is. We should really know shortly after the reading week. And if the exam, I think that in either case, we'll try to maybe schedule some review session for you so you can still ask me some questions. I think that's really necessary since it's cumulative, right? But we'll see. And drop deadline will be March 17. I hope everybody will stay because this course, unfortunately, is offered only once a year. So I don't think you guys really want to drop, right? Stay, okay? So drop deadline will be 17th of March. Before that, you will be able to know your result for written test 1 and programming test 1, which will be 20% plus 1, 2, and 3. All 3 labs, as long as you submitted it in time, you also got the corresponding percentage. So you pretty much know some components of your course already before the drop deadline, if you really have to make the decision, all right? Any question about the calendar over here? Are we good? Okay, so let me return back to syllabus. And that's the coverage which I just spoke about over here. And the weekly schedule, so definitely attend the lectures to get some bonus at the end. And for the lab sessions over here, they are optional. So guys, I don't want you guys to really get surprised. I would say to be more precise. In principle, they're optional. Okay? The only circumstance I can think of would be, for whatever reason, if our reservation in the Witness Small Center wouldn't work for the particular test, they might just let me know in the last minutes, in which case we may have to take the test in your scheduled lab session instead. But I will make sure I let you know way earlier in advance. That's the only exception I can think of. Okay? Except the Wayland Small Center not available in the last minutes. Okay? And what about the topics? So we're going to spend the next, today I don't think we can really get to the review on math. We can do a little bit of introduction, some motivation for why this course could be useful. And starting from Thursday, we're going to do some review on the discrete math. We're going to do predicate sets relations. That will take us maybe until next Thursday-ish, hopefully. And then we're going to spend a huge amount of time on this case study called a bridge controller. It's a typical reactive system. You will see how amazing. You start with something incredibly simple, do some proofs about it. Eventually, you can refine that down to something that's closer or much closer to code. Okay, that's something we'll do. We might do that for at least 4 weeks or 5. Okay, we'll see how that goes. And then we'll definitely also try to cover another case study with a slightly different flavor. That's like an FTP protocol with a sender and receiver. Okay, and the textbook I supply on the e-class, you can definitely refer to the textbook whenever you find any gap in your understanding in the lecture. Or if you're more hungry, about learning more case study, you can definitely refer to the textbook as well, or just want to purchase one. That one's completely optional. I'll leave that to you. But I know you got many other things to do, which is okay. All right. That's about the syllabus. Do you guys have any question about the syllabus? All right. Yes.
Can I ask the question related to
Yes, go ahead, please. Yes. Wow, I didn't expect this question this early, okay? Then, guys, I don't want to lie to you. I typically only think about whether I wouldn't call it curve up or curve down. I don't really shift the distribution just rightwards so that we got a normal distribution. That's not what I normally do. I can tell what I typically do, okay? once we got the row marks for everybody, right, I'm going to sort them from the highest to the lowest. And then I will try to look at those people maybe around the cutoff. Let's say, for example, let's say those people whose row marks maybe is less than 50%. I'll try to look at them and see, okay, how did they did? How did they do for programming test? How did they do for written test? Maybe they did pretty well, it's just that they screwed up the exam at the last moment. So maybe I can still pass them. That's kind of the minor adjustment I might do, but I cannot guarantee anything. Those are something that only myself would know the detail. I wouldn't even reveal to the department. Of course, if you really petition the course, I can maybe have to explain, but I can tell you that some adjustment I'll do. And this year, since we also got attendance check, so if I see, okay, maybe Jackie, he failed the exam terribly. He also didn't do so well on the written test and programming test, but he comes to the class every time. Maybe he's only about maybe several percentage away from passing. Maybe I'll pass him. Maybe, right? It's a little bit subjective, I know it sounds, but I just want to make some example for you, right? But that's a fair question. I totally understand your concern. Because if you fail this course, you need to wait another year, right? So, I know. But do your best. Guys, any other questions? Awesome. All right, okay, we're done with the syllabus. Let me just present a little bit more slides. And for those of you who might need accommodation on maybe extra time for your test, please let me know. And then I'll try to make some proper arrangement. And let me just do a few more slides, and then we'll take a short break, and then we'll do some introduction to the course. Okay? And you guys are either in software development stream or software engineering program. So eventually, you want to be a professional software developer. I'll talk a little bit more about the code of ethics about being a professional engineer in the next slide, in the next set of slides. But for now, let's just tell you that it's all good what you did in 2011 or 2030. You're given some JUnit test cases, you try to program according to it, it's all nice. But I think this course here, we don't do any Java coding. We don't really try to tweak the performance of your SQL database queries or C functions. We don't do that. Instead, we try to think in terms of sets and functions, mathematics. So that's actually a very nice way to train your mind to think above the code level, which is very important too. That's something we'll do in this course. So thinking abstractly. So you heard about the term abstract a lot throughout your degree. So what does being abstract really mean? That means not so many details. If you program in C, you have to worry about, oh, should I do some free or should I do some malloc? Or should I do some pointer arithmetic? But when you think abstractly, you don't necessarily have to think about those kind of issues. Okay? And for this course, could be nice for your programming interview, not directly relevant, but if you're very good in thinking abstractly, I think it's really nice for you to come up with something creatively. Okay? That's something you might be able to get some inspiration as we go over the example. And in 2011, you use concrete data structure to learn in Java. Right? You can actually see if your programs actually work. But in this course, it's more about abstract machine. I'll talk about what machines really are in lab number 1. You will see some idea. But abstract over here means it is not a very particular programming language you have to program in. You got to think in terms of variables being sets, functions. And for functions, by the way, which we're going to do on Thursday, do you guys remember the difference between a partial function and a total function? At least have you heard about the terms before? Yes, maybe, okay, maybe back in 1090. If you forgot about it, don't worry, we're gonna review. Once I review with you, I assume you're the master of that. Don't worry, we're gonna do that. So we're gonna learn about many relevant math constructs that you learn in 1090. We're gonna see how useful they could be, when you try to model the system. And just a link of interest, if you want to see how they do interviews at Google, they actually let you do things on a blackboard. You don't necessarily have to program on the IDE. Okay, study tips. Come to the class. Don't really take the recording as a replacement for classes, please. And then ask questions. And you can take notes if you want to. And then General tips, I don't want to say too much. You can read it if you want to. It's basically saying hard work is definitely important, but it wouldn't necessarily guarantee that you will really perform so well in the test. It's cruel facts, but we just got to deal with it. So, what's really the best way for you to learn? Make sure you stay on top of everything we talk about in the class. Review them constantly. If there's any spare time you might have, you may just want to reach out either to me or maybe try to go to the textbook or other relevant textbook to look for more example for yourself. I think that'll be useful. It's actually true for every course, right? I'm not going to bother you too much about these bullet points, but you can take a look. All right, guys, that's basically about what I want to say about administrative issues for the course. And the next set of slides will be more about this course. Do we have any question? Everybody happy? I hope. I'm sure you'll be happier throughout the term. All right. Why don't we take it's now 12:21. Make sure I finish the lecture by 12:50. That should be the end time. Why don't we take just about 3 minutes break? How about 4 minutes until 12:25? Don't go too far, and then we'll cover the first lecture for introduction.
Do you recommend us to take 4350 after this course?
Are you in software engineering?
No, I'm in a software development stream, so it's not mandatory.
Oh, it's mandatory. It's not mandatory. It's a good question. We can have more, like a deeper talk maybe later. If you ask me, I would say yes. 4315 is actually also a very nice course to talk. Especially, it takes a different approach for you to do verification. Yeah, drop by my office hour later. We can talk more. Yeah. Hi.
So some students that I know are taking this class and 4315. So there's like 1 week, I think it's in March or something like that, that you have like, I think a written and I think a programming test for both classes.
Okay, but they are not. Yeah, I know. They're not exactly clashing, right? So
They're on the same week.
on the same week.
I
Yeah.
was wondering if you would be open to maybe like changing one of the dates.
Yeah, it will be different. I know what you mean. Because it's only about not very many students in that case. So I would say, since you already know the dates, you want to definitely make sure you prepare for that. And then, since I know it's a different day. Maybe one is on Monday. Sorry,
like
Tuesday. The other one is more like Tuesday and Thursday, right? It's on the same week, but you still got some gap. It's not 100% clash. So I may not change it. Say, since you know the dates already, try to get some necessary preparation beforehand. That's what I would say. Yeah.
For the tests, are they
In person.
but then they're all equals basically.
Yes. You can think about you go to the app and log in
Yeah.
using the dual mobile verification, and then you take the test.
Last year you had one wrong question for one right question, one right answer. So
Possibly.
multiple choice.
Possibly.
Are you gonna have that the same this year as well?
You mean the same, the
Like
question?
same rule, like multiple choice, and then one wrong answer takes away.
Oh,
the
I see what you mean. I see what you mean. Yes.
Yeah.
Yes.
So lost a lot of marks.
Yes.
Because of that.
Since it's going to be E-class, so I think I'm going to follow the same scheme set by E-class. It's going to be, I see what you mean. It's going to be the same, unfortunately. But since I don't really invent a marking scheme, I'll just follow whatever that's preset by the E-class. Yeah.
Okay.
Yeah.
Yeah, that's basically it for now. And then for the written test and the programming test, are they both multiple choice or no?
Oh, for programming test, you have to come to the lab and do in Rodin.
Okay.
Yeah, but for written test, you'll be over E-class, multiple choice, mostly. Yes. Yeah.
Question, do you have office hour today?
I do. Oh, I should really confirm that. Yes, I do. Today will be 3:30.
Oh, it's 3:30.
3:30 to 4:30, I think.
Okay, so can I drop into your office hour?
Yeah, absolutely. Office hour, you don't need to ask anything, just show up in the office hour. I should be there. That's okay. Office hour, you don't need an appointment. All right, guys, just get ready. We should really start very soon. Okay, we'll start in just one moment. Yeah, you can assume that later, whenever we take attendance, we'll take a break at the same time. So you can definitely stretch your legs, walk around a little bit, and then we'll resume. Sometimes the material could be a little bit dry, could be. So maybe taking a short break can help. Okay, let's now resume. Just confirm one thing, which I forgot to explicitly say. For your syllabus, remember I put the office hour over here. Okay, so it will start today. So today, Tuesday, tomorrow, Wednesday, and also Thursday, you can already drop by my office hour if you want to. But if you really want to speak to me by other times, by appointments, that's also fine. Just send me an email. We'll do that. Okay. All right, let me now go on to the introduction. Today, we still wouldn't cover too technical stuff. We'll do the math review, I promised, on Thursday for sure. So today, just go over some slides, have some conceptual sketches about how the approach is going to work in general, and give you guys some optional references which you can look into. That's basically what we're going to do. Okay, we got about 20 minutes-ish. Okay, let's see how much we can do. That might be just a perfect timing. Okay, introduction. Learning outcomes, let's understand what's really safety critical system. I know you only learn about safety critical system in 4315. You know the title is actually called mission critical. Of course, you're gonna learn about the difference between safety critical versus mission critical. But why don't we learn about the definition right away? It's very straightforward, okay? And then it's also very relevant to talk about for professional engineers. I think many of you, when you actually go into the industry for your career, you might be required to be licensed as a professional engineer. It's a very common requirement. Even for myself, for me to teach you guys, for me to be qualified, I also need to be licensed, but in a limited way. Anyway, so that's details you wouldn't have to be bothered. But in order to be a professional engineer, you need to comply with the code of ethics. There will be some little passage we can read together just to let you know why this course at 4315 will be so relevant for you to become a professional engineer. We'll talk about it. And formal method. You may not have really gotten any exposure to formal method until now. So this course at 4315, we try to show you a way that you can think, number one, think above the code level. You think more in terms of mathematics. And number two, you don't really try to debug your Java code in Eclipse by setting breakpoint or even just do system.out.print line anymore. The way you debug is by trying to prove something there, but you cannot really prove, then you're going to want to extract some insights from the proof. That's basically what we're going to do. Full method. Everything will be formal rather than just testing. And we're going to draw some quick notion about verification versus validation. There's also some critical difference between them. And then model-based system development. That's basically the paradigm we are adopting for this course, namely by refinements. Okay? Not too sure if I can cover everything here. I'll try to go a little bit slowly to make sure concepts are actually clear. If we cannot finish, we'll definitely finish in the first bit for the first part on Thursday. Okay, let's go one by one. Safety critical system. Definition. Apparently, it should be safety critical. So what does it really mean when you fail to develop a safety critical system? The consequence would be, could be injury or death of people. Or could be simply some damage to equipment and property. Of course, you'll lose money, or it costs your boss to lose money. And also, it could be harm to the environment, in which case you might be subject to some lawsuits. You might just go to jail by actually failing the safety critical system. Right? So based on that, that's a very simple definition here, just safety critical. As long as it has a consequence to compromise the safety of either individuals or the general public, then the system itself is really safety critical. Can you guys think of any example? I do have some in my mind. Do you have any example?
Nuclear power plants?
Wow, you read my mind. That's exactly what I'm thinking. Good for you. I'll write it down. Okay. Absolutely. Okay, I'll write it down first. So we talk about safety critical system. Guys, one thing I will need you to really do for me, sometimes when you see me writing on an iPad, I forgot to switch on the projector shot on me to say, switch it, okay? Sometimes I will forgot. Safety critical. Safety critical systems. Nuclear power plant, that's a very nice one. And do you guys know the name of the nuclear power plant that's nearby us? Darlington, Darlington, yeah, that's okay. Pickering is the area. Okay, Darlington for Ontario. Okay, for example, apparently if the nuclear power plant fails, you know what the consequence might be. But luckily, I think the engineers who built that Darlington nuclear station for us are rather professional, so we are fine. Okay, any other example? Yes? Absolutely. Auto driving. Okay? If no, let me provide one. Do you know pacemaker? Yeah, you may have to install some pacemaker in your heart to help your heartbeat, right? Pacemaker, definitely. For this, I will encourage you guys to look for some link. McMaster University, I think about back in 2010 or 11-ish, they presented to the public the so-called pacemaker challenge, in which case they want to say, given the pacemaker model or implementation, how can you certify it's fit for use? You can look at that webpage to see some a little bit background. Okay, that's optional. I'll write it down here. Look at the pacemaker challenge. McMaster. The McMaster in Hamilton. Okay. Any more before we leave it? Okay. If no, that's fine. Anyway, if we can encounter more, then we'll definitely mention. So these are just the typical safety critical system. I'm not saying that we're going to build these systems in this course. It's not possible. We only got 3 months. But maybe some critical units over there, you can get some inspiration for how to build them in this course. Because you have to worry so much about safety, right? Which will be something called invariant property, as we will talk about later. Oh, actually, there's something I can also mention. One more thing. Bridge controller. Conceptually, thinking this way. Let's say here we got some mainland. And over here, we got some island. And let's say you're the civil engineer, or you're the engineer to really build some system for that. We want a bridge over here. We want to have several constraints. Number one way. The car will either go from mainland to the island, or it will go from island to the mainland, not simultaneous. Otherwise, you got collision, right? Number two, limited capacity. There might be some limited capacity to say, in the island and also on the bridge, how many cars maximum there could be. Maybe 1,000, maybe 500. There's got to be some restriction over there. So if you put any sensor over here on the mainland, you want to make sure if we have already reached the maximum of cars in the island and the bridge, we cannot allow any more cars to go out of the mainland to the bridge, right? That makes sense? In that case, there should be like a red light on the mainland, all right? So bridge controller is also a typical safety critical system, and we're going to see how to build it in the lecture, okay? That's something to look forward to. I'm sorry, not the next week, but possibly from week number 3. We're going to make sure you're okay with the math before we get there. Okay, that's safety critical system. And professional engineers code of ethics. Have you guys heard about PEO? Professional Engineers Ontario. So for those of you who might want to get licensed, let's take a look at their code of ethics. Okay? Code of ethics means if you want to maintain your status as a professional engineer, you want to make sure you satisfy all the requirements over here. Okay, basic guide for professional conduct. And you want to make sure you have responsibility for the society, employers, clients, colleagues, and also the engineering profession, meaning that you want to be competent technically always. Okay, you want to keep up to date for any new knowledge. So we got certain rules over here. You want to be fair, you want to be loyal, you want to be dedicated to the public. You want to make sure you think about the public rather than yourself. You know, for example, I remember I wasn't really licensed by the PEO. I was licensed by another province, Saskatchewan, their Professional Engineer Society. And when I was taking, you know, for you to be licensed, number one, you want to make sure your degree is more like an engineering degree. Otherwise, you will need to take some technical exam to say, if they think you lack the background for practical logic, they'll give you some technical exam for practical logic, and etc. And the second exam you got to take is something called ethics exam, you know, code of ethics. In that exam, you're supposed to demonstrate your mindset being an engineer to make sure you pass. I remember one of the questions was, let's say you are hired as a professional engineer in some, let's say, nuclear power plant. Well, let's make it a little bit less extreme. Let's say some factory. And somehow internally you realize the water that's actually produced by the factory is toxic. So would you rather be a whistleblower to tell the public, or would you actually report to your supervisor first? That's kind of the conduct you want to make sure you maintain properly. There's no really right or wrong answer, but you want to make a decision and try to justify it. That's kind of the stuff you guys want to worry about. That's, of course, beyond the scope of this course. And also high ideals. And 1, 2, and 3 are really beyond the scope of this course. But number 4 is you want to have the proper knowledge to be professional. So in this course, we're going to show you how you can do formal specification and also how you can do formal refinements and how you can conduct proofs. That's really the knowledge. And also, you want to be competent. If you pass the course, at least you are competent. You're ready to take some career and then try to get yourself better. Just the minimum knowledge. And consequence of misconduct, if you're lucky, you just get suspended or deactivated for your membership. If you're not lucky, you got lawsuit, you might even go to jail. Right? Well, I just want to say, you want to maintain yourself as competent as possible when you become professional engineer. For civil engineer, how much pressure they might have. Let's say they're going to build a bridge between the tips of 2 mountains, let's say. At the end of the, before they can really open the bridge for use, the engineers will have to stamp their professional stamp on the paper to say, now me, Jackie Wong, I certify this bridge to be safe for use. 5 years later, who should they hold responsible for? Engineer, for sure. So that's why you want to be so careful about your profession when you do it. All right, just give you a little bit more cross-references. It's only for your information, okay? So there are different ways to really address about how you can perform, let's say how you can perform your job professionally, okay? So we got something called industrial standards. So I'll give you the names of the industrial standards. So all the industrial standards I supply, they are proprietary, which means they charge you if you want to look at the contents. I'll just mention the name to you. If you're really interested, you can just Google for the industrial standard. There might be some other people who talk about the standard, so you can get some idea. But I wouldn't talk too much in the course. So one very relevant one is called the DO-178C. This one is actually mentioned quite commonly. It's more for building airplane. Oh, safety critical system, airplane, for sure. That's definitely safety critical. And that one is more about, in order for the airline company to really declare their airplanes are safe and fit for use, what kind of verification and validation procedure should they undergo before they submit for certification, right? So that standard talks about it. And similarly, for the nuclear domain, that's for 7432. So when I was doing my postdoc, I was involved in a very small part of the project related to OPG, Ontario Power Generations. So they wanted to really refurbish their nuclear power plant like a shutdown system. So they actually look at this standard very substantially just to see later on when they want to justify the refurbishment, they want to make sure they satisfy the standard. So that's also very relevant. Okay, so let's now try to give you just what you need to know. But for these two standards, feel free to Google and find more information. But what should you know that's relevant to this course? Number one, the system requirements should be precise and complete. Okay, so let me just write it down over here. That's something I will also mention a lot throughout the course. So when we talk about precise, that simply means no scope of multiple interpretations. And you guys may take EECS, I believe 4312, later, not now. It's the requirements engineering course. So in that course, you try to see how you can elicitate or try to get some requirements from your customer. So the result from that would be some requirements document, which tend to be written in English or some whatever natural language you are proficient with. But those kind of a document is still very imprecise because sometimes when you read some English passage, you may have multiple interpretations of what is supposed to be done. So that's not ideal. And when we say precise, what could be the most precise language to use? Math. Okay? If you write some predicate in using the universal quantification, there should be no misunderstanding about how that should really mean otherwise. So, math. Okay, we'll definitely review what you should know. And complete. There'll be no missing scenario. This is something I'll try to exemplify maybe later once we get to the bridge controller. This simply means as follows. Let's say there are 100 different scenarios that you may actually run this particular bridge controller system. Does it really matter to say 99% you'll be safe? But there's 1%, there's 1% of car collision. Is it acceptable? Not really, because you want it to be 100%. So you want to make sure for every possible scenario of your system is 100% safe, and all the safety properties can be satisfied. Okay? Okay, so all possible executions of the system under developments exhibit the safety property. Okay, that's also very important. We'll talk more once you see the precise model later. Okay, and the second criteria will be the implementation really conforms to the requirements. This one's interesting. Let me draw you some conceptual diagram. And that might just take us to the end of the class, which is okay. Okay, and then we'll finish off the rest next time. It'd be very important for you to see this diagram, how you can build it from scratch. Okay, let's talk about it. Let's say this. Let's say I develop some Java code or C code, doesn't matter. So let's say I have my implementation. It could be in Java, could be in C, could be in Python, or can be anything, or even just Sketch. What's my goal? My goal would be, I want to say, if I try to run this working system, is it ever going to violate certain property that's considered safe, critical? For example, let's say some safety property. So I'd say here would be some safety property. Okay, and for example, there might be some sensor value. Should be maybe always less than certain threshold, I'll say T. For example, let's say we have a sensor monitoring the temperature of some nuclear reactor. We want to make sure the temperature doesn't go too high. If it goes too high, then we've got to be careful. right? There should be some corresponding measure to really alarm the system, okay? Given this, we would like to know whether or not the safety property is always satisfied. But there's a problem here. This may just be Java. This over here might just be some relation or predicates. They are not in the so-called same semantic domain, which means they are not the same language, number one. If you look at these two, not in the same semantic. Semantic simply means meaning. That means cannot be compared directly. So that's why it's really almost impossible for me to really say, okay, this property here should be exhibited by this Java program, just by arguments. It's not possible. What should be the professional way to do this, which we're going to learn in this course? The idea is actually very reasonable. If the semantic domain are not the same, why don't we translate each one of them into something that's in the same semantic domain? That's the idea, all right? So what we're going to do is as follows. We're going to formulate two things. Formulates. And we'll also try to formulate over here. Okay, we're going to formulate this into some formal specification. And we're going to see exactly what formal specification is like in your lab number 1. And then we're going to formulate the property also into formal invariance. Okay? You may have seen this invariant maybe before, maybe in 3101, loop invariance, right? Similar idea. Loop invariance should be maintained for all the iterations. System invariance should be maintained for all the system execution. Similar idea, okay? And then once you got formal specification, once you got this, what you really can do is you can prove implication. For about implication, that means running the system over here imply the invariant can be satisfied. Okay? You can see in order to really do this, what we do actually is to do on their formal representation. There's only one potential risk you have to address. How can you be sure this formulation over here is accurate, right? Otherwise, when you say, oh, I can prove this rather easily, well, by the way, you can prove false implies anything, right? So if you actually formulate something that's junk, like a false, you can prove anything. That's not very useful, right? So here, you want to make sure the formulation over here is also accurate enough. Okay, I'll take 1 more minute. I will let you go in time. Accurate or not? That's also very important. So in this course, let me make a recap, and then we're done for today. Our goal always is we want to somehow prove that our system, which might be our system satisfies certain property. In order to do that professionally and formally, we need to formulate each one of them into some formal construct using math, and then prove something over here. That's basically what we're going to do for this course. Okay? Guys, any question? All right. What should you do before Thursday? Please install iClicker to get it ready, and then we'll take some trial attendance. And then you can already start looking through the stuff for the course. I'll try to upload possibly a math review lecture maybe before Thursday's class. You can also take a look. Guys, take care. I'll see you on Thursday.